Welcome back. Well, it is time for our next lesson. And coming back after spring break, we're starting our next unit, and this is going to include understanding the graphical side of all of the mathematical content that we've talked about this year. So we're going to begin just by reviewing identifying a function and specifically identifying a function from a graph, because we've recognized that that is not always as simple as it may seem to us, to you guys. So I'm going to go over this lesson. Let me pull it up real quick and show you what we're going to be doing. All right, so here it is. This lesson is, like I said, on identifying functions from a graph. So first off, this is our skill, identify. We're going to be able to look at different examples and tell if one is a function or if one is not a function. So that's the skill we're going to be talking about today. Now, the concept is a function, and this is a majorly important concept in all of math, and especially in 8th grade. We have our guaranteed standards, F1, identifying functions, and F4, constructing or writing the functions. So we're going to talk and review the idea of a function briefly in this lesson, and then we're also going to narrow it down to just being able to identify them from a graph. So today we should be able to identify functions from a graph by the time we're done with this. Now, just to kind of relate this to something that you would already understand or already know is this prior APK, our prior knowledge here. Can you be in two places at once? Well, obviously the answer is no. And that is why our location in space, or our location anywhere, in this example it says you at home or you at school, is we can only be at one place at a time, and that is how a function works. We can only be at one place at a time. We can't be at two places. That would not be a function, right? So this idea of that we can you can only function in one location at a time. This is an idea of a function. We know we can't be in two places at the same time. So let's look at the mathematical definition of this and then use that to help identify them on the next slides. So let's begin by reading this definition. A function is a relationship. Now, I'm going to stop right there, actually, and let's make sure the word relationship is important here. A relationship in this case is between two different things. So a function is a relationship between two things. And when I look at our examples, I see that in each one of these, there's two different things going on. Here's one, the x value or the x-axis, and here the y values or the y-axis. So when I say a relationship, I'm talking about the relationship between x and y here. And I see that in this example, x and y, and I see that in this example, input x and output y. So in each one of these, we have a relationship between two things. And in this case, it's x and y. Now, a function is a relationship where each input, okay, let me slow down. Each input is assigned. Now, this word assigned right here is pretty important, where each input is assigned to exactly one output. All right, so let's think about that. It's a relationship. We already know we have x and y here, but each input. Now, let me tell you which one is going to be the input for us. We're always going to have that the input is going to be our x value, and that we are going to have x is going to be our input, and we are going to have y is going to be our output. So if it says each relationship, a function is a relationship where each input x is assigned, well, that word assigned kind of makes me think that like it's given to it, or it is matched to it, or it corresponds to it. So a function is a relationship where each input x is assigned to exactly one output y. Well, let's look at this first example. Let me erase this real quick. And let's see if we can understand what that is telling us. So the input, in this case, I'll say the input is going to be green. So the input would be -3. The input, or an input would be -2. An input would be -1. This would be 0 right here, 1, 2, and 3. So those are all our inputs. Now, each one of those inputs has to be assigned to exactly one output, to exactly one y value. All right, so let me see if I understand what that means. If the y values, let's say I'm going to do these ones in orange, the y values are all these numbers, and we could say that 0 would be right here. Let's look at this function and see how each input is assigned to one output. So let's just choose this point right here, this point right there. All right, so if that point right there, let's look at our input. Our input, I can see that it's about -3, okay? So our x value is -3. Now that x value needs to be assigned to exactly one output. And let me see if I understand what that is. So the y values are over here on the y-axis. So if I go to -3 for x, and I go up to the function where that little point is in blue, I only go to one place on the y-axis. Now, I don't know what that number is in this example, but it doesn't really matter because it only goes to one number. Let's check some more of these and see if we can keep seeing this pattern. Let's go to -2 on the input side. -2 here. I draw a line to the function. The function right there, in this case, is in blue, and it should be only assigned to one output. Let's see, if I go to the y-axis, yeah, there's only one place on the y-axis this function touches. Let's check one more and double check if this pattern is holding. Let's check the input 1. Let's check the input 1. So the input 1 is right here. If I draw a line to the function way up there, and here I can see that that's a point of the function. What is the y value that goes with it? I don't know. It's about 3.53 something. So again, there's only one output. So you can see on this graph that each one of these inputs, -3, -2, -1, all the rest of them, if I go up to the function, there's only one place that I would go to on the y-axis. That means it's assigned only one output. Okay, so let's look at this non-example here and see if this clears anything up for us. If I go to, let's just say I'm going to go to the input +1. So if I go to the input +1, I want to look to see where is this relationship on the graph. And let me do a point in red where I could see with the input +1, I can see, well, actually, this is confusing already because I could go up to this point of the relationship, but I also could go down to this point of the relationship, which I don't think that is going to meet our definition of a function. If a function has to have each input, 1, is assigned to only one, exactly one output, in this case, look, if I go all the way up to 2, that is my output. But at the bottom, it also goes down to -2. This is not a function because the input 1 is assigned to two different outputs rather than one specific output. So the non-example is not a function because the input 1 has two different outputs. All right, that makes a lot of sense here. All right, well, let's go back and look at our other examples and see how they line up to our definition. So again, a function is a relationship where each input is assigned to exactly one output. So let's look at the table here, right here in the middle. So here we have a table. And let's see how this table, how each input is assigned only one output. So to begin with, I have -3 on the x column, and it goes to only the number 1 for y. There's no other number 3s on no other inputs that have different outputs. Okay, and same thing for -2, that goes to one output, -1 goes to one output, 0 goes to one output, 1 goes to one output. Each one of those numbers on the input side goes to exactly one output, as you can see by my blue arrow. Now let's look at the non-example. In the non-example table, if it's not a function, we should probably have one input going to two outputs. So let's see where that would be. To begin with, I have 0 is being output to 1. Okay. But then if I look at the next point, I have another 0. So I have the same input, the same exact input, 0. But this time it's going to -1. This is not a function because the input 0 goes to two or is assigned to two different output values. It's assigned to 1 and -1. This cannot be a function. If we look even farther, the input 1 is assigned to 2, and the input 1, this one right here is also 1, is assigned to -2. So again, we cannot have this same input being assigned to two different outputs. That would be like me being in two places at once. I can't be assigned to two different places. And then finally, let's look at the diagram. Let's finish this up with the diagram because here, you might be expected to see things like this graphically in not a normal kind of situation. Here I have the input -3, and I can see that it actually has an arrow going to the output 1. Okay, so one input, -3, to one output 1. -2 is assigned to 0. All right, well, that's good. Let me go ahead and just highlight that that's good. -1 is going to 1. I see something here that might be confusing to some of us. This input -1 is also going to 1. is that okay? Does that meet our definition of a function? Well, let's go back to the definition. A function is a relationship where each input is assigned to exactly one output. Okay, well, let's check. -3 is assigned to exactly 1. So -3 goes or is assigned to +1. Okay, one input is assigned to exactly one output. Good. Well, then let's see. We have another input, -1. And that one is also assigned to 1. Does that meet our definition? A functional relationship where each input is assigned to exactly one output. Well, the input -1 is assigned to the output 1. Yes, it is. So each input is assigned to exactly one output. It doesn't matter that they're the same outputs. This is still an example of a function. And then finally, let's look at the non-example of this diagram down here. In this diagram here, I can see right away at, let me highlight this for you, at 0 as my input. That 0 is assigned to both 1 and -1. That would be like Mr. Lewis assigning me to teach both history and science at the same exact time. I can't do it. I can't be assigned to 2 different places at once. So therefore, that is not a function either. Okay, well, let's look at some of the problems and see if we can now figure out how to identify a function from a graph. All right, so let's do our first problem. The problem says a relation is shown on the coordinate plane below. Is the relation a function? Explain. Well, let's see. First off, when I look at the problem, I see that I have a coordinate plane here. That's this XY grid. And then I see this, actually I see 2 blue lines, and that's the relation here that I'm looking at. And I have to determine, is that a function? And then I have to explain how I know. So let's go through our steps. Step 1, identify the first input value, x, on the left side of the graph. Okay, well, our input values are the x values. I'm going to go all the way to the left-hand side over here to -7. Now, if -7 is my input, step 2 on the problem, on the step say, determine the corresponding y output. Okay, well, let's see. The y values are here on this y-axis. So if the input -7, well, already I can see there's something off here. I can go both up to this relation or down to this relation. Now, that's mathematically allowed, but is it a function? Well, step 2 says identify the outputs that correspond with it. Here, I have an output of +7, but down here, I have an output of -7. So I already can tell that this is not going to be a function because this is not meeting my definition right here where it says each input assigns to exactly one output. Here, my input -7 is assigned to 2 different outputs. Done. This is not a function. Now, the next step says repeat for each x coordinate. Well, I got lucky on the first one, so I don't need to do any more repeating on this. Step 4 says check that each one maps to only one output. It doesn't. This input is assigned to 2 different outputs. This is no longer a function. Well, because it's not a function, let's go ahead and see how we would explain that. What would I write? Now, luckily, I don't have to write it. We have it typed here. But let me break it down for you, the different parts. To begin with, I want to make sure that I answer the question and restate the question as I do that at the same time. So I would say this relation is not a function. And let me stop right there. That's me restating the problem and answering it all together. But then I also need to go a little bit further. I need to cite some evidence. Like, what are the numbers that tell me it's not a function? Well, it was this -7, +7 deal here. So here's me citing my evidence. Because the input -7, right, -7, my input here, is assigned to 2 outputs, 7 and -7, here and here, that's not a function. Now, why does that matter? Well, that's the next part. Let me explain my evidence here. Here, I'm explaining it. All functions must have each input assigned to exactly one output. So I would say this is not a function because the input -7 is assigned to 2 different outputs, both +7 and -7. And all functions have to have exactly one output assigned to it. So this is not a function. Now, look at your graph here. Yours is the same exact prompt. A relation is shown on the coordinate plane below as the relation of function explained. So now's a good time to go ahead and pause the video and figure this out on your own. Also, I would write down your answer, your sentence here, so you can compare what we have when we come back. All right, welcome back. Hopefully you paused and tried this one. Let me go ahead and tell you, this one, this example, this is a function. I know this is a function because each one of these inputs, anywhere I go on this x-axis, any one of these, I only go to one place. I only go down to one place on this function, on this relation, which is a function. So I would say, I know this example is a function because each input is assigned to exactly one output. All right, let's look at another example. Okay, here for our next example. The question says a relation is shown on the coordinate plane below. Is the relation of function explained? Okay, well, let's see. I've got an XY grid here. It's a little bit different than normal. The 0 is not right in the middle, but that's okay. And then I see this blue line, which is our relation. So we're tasked with determining, is that a function? And then explaining how we know it is or is not. All right, well, let's go through our steps again. Identify the first input value x on the left side of the graph. Okay, so that's going to be -7. And step 2 says, determine the corresponding y output. All right, well, let me see. If I just draw a line going down here to this point of this relation, I see that it only goes to one output here, -8. So the input -7, is assigned to -8. Okay, so far it's a function. Step 3 says, repeat for each x coordinate moving from left to right. Okay, well, let's go ahead and start that. I'm going to change colors here so we can see the difference. I'm going to go to -6 on my x-axis. Let's check to see what the y output is. If I go to -6, I draw a line down to my relation. Here it is. There's only one point that it's assigned to, and that would be -9. So the input -6 is assigned to -9. Okay, let's repeat this over again. Let's check the next one. -5 here. This input, -5. Where's the relation? Way down here. What is the output? Oh, it's maybe 9.5. Okay, so, or -9.5. So again, one input, -5, is assigned to one output, -9 point something. Well, if we were to continue this, and I were to check every single x value, go from -4, if I move that one down, it only touches the relation at one place. Here, -3 touches the relation at one place. Every one of these x inputs only touches the relation at one place. So this is a function. My problem is a function because each input is assigned to only one output. So again, how we would write that in a raised sentence, or how we write that in a sentence, would look like this. This relation is a function. Answered the question, restated it. Because each input is assigned to exactly one output. That's my evidence there, right? Each input, I did the work seeing that each one's assigned only one output. And then why does that matter? Because all functions have to have each input assigned only one output. All right, let's look at your problem. Your prompt says a relation is shown in the coordinate plane below. Is a relation of function explained? All right, pause the video now. Go ahead and answer the question yourself, and then come back to see if you got it right. All right, welcome back. So it says a relation is shown in the coordinate plane below. Is the relation a function? Let's see. Well, when I start, I'm going to go ahead and start over here at -7. If I start at -7, I see I only touch the relation in one place. Okay. Now, to avoid a little confusion, I'm going to move over here to the input -2. So when I go to the input -2, where is the relation? Well, it's up here. It is down there, and it is also down here. This relation for the input -2 has 3 separate outputs. This is not a function. If I were to write these 3 points as a table, it would look like this. The x input would be -2, and the y output would be 4. The x input -2 also is assigned to -2. The x input -2 is also assigned to let's just say it's -8. The same input is assigned to 3 different outputs. This is definitely not a function. All right, well, that's all I have for these examples for you today. I would like you to now go ahead and leave this video and go do the independent practice problem on the Google form in the same assignment. All right, see you guys next time.